Welcome to the computer science crash course. The focus of this course will be more towards software rather than computer hardware. And the course is not intended to be a formal computer science course. This is a course to give you a high level understanding of what computer science is. At the same time, you'll be gaining a level of depth of understanding of the field. So, without further ado, a computer is just another name for a calculator. Computer science, you might as well call it calculator science. Computer software, you might as well call it calculator software, right? And a computer is not like any other calculator that just does your basic add, subtract, multiply, divide. A computer does much more. It can also compute logical statements. If you combine this and this, if you do this, then this comes next. Those are logical things. And of course, a computer does not really understand creativity like we do. So they lack that ability, and that's why they need humans to tell them what to do. Because at the end of the day, the computer only does logic for you, right? And formal logic, once again, is anything that involves the phrases if this, then that. That's a logical sequence of things, right? Or do this, or do that. That's purely logical. Nothing ambiguous about that, right? And computers have a tough time with ambiguity, right? And also not doing things. Those are all formal logic concepts. Now, about programming languages, in order to describe things that you want a computer to do for you, the computer doesn't understand language like we do, right? So we have programming languages that enable us to speak with the computer. And even in the domain of programming languages, there actually are translators. And the programming language is, again, just a systematic way of describing how a computer should perform logical actions on data, right? And programming languages vary because some languages are better suited for different tasks than others, right? Data is anything like numbers, letters, words, sentences, audio, photo, video. All that is data, and anything you can think of that's logical that you want to do with data, computer can do it for you. Once more, the computer, at the end of the day, only understands numbers. That's sort of false because the computer really understands electricity and not numbers per se. And what the computer interprets as numbers is based on the software and language that you develop the software in. But a computer just looks at current flowing through the circuit Again, this is not intended to be a computer science course that focuses so much on hardware, but at the most basic level, when current is flowing through the chip, it's where you see fancy looking lines on the computer chip. The current is flowing through there, and you don't necessarily need a big copper wire, big cable to have electricity flow. That's why you can have thin little slivers of conducting material on a chip and have electricity flow through it. And then depending on how much current is flowing through the chip, the computer will be able to combine the current and interpret it with the language that you have it interpret in. Well, enough about hardware. When it comes to software, the thing is, when you want computers to do things, you can go about it by describing a broad set of actions or a long list of actions that come together or coalesce to become one big thing. For example, let's take sports, basketball. Michael Jordan had to know how to dribble and how to shoot, how to defend. All those things are different actions in different scenarios, right? If a defender is on you, you either do this or that, right? Of course, basketball involves much more creativity than logic, right? But basketball is a big task. More specifically, it's a sport, more of a sport than a task. And when it comes to computer software, softwares are large, broad actions that fall under a specific category. So, for example, you have Microsoft Word, Microsoft Excel. You have your browsers that interpret web pages for you and display the videos and all kinds of data for you. If it wasn't for computer languages and computer software, every single little teeny tiny tedious thing that the computer has to do, all the if this then that and do this or do that, add this, subtract that, all those things you would have to tell the computer to do it step by step. Well, or you could specify those things into one big list. The list can have thousands or millions of items, which we call code, and put it all into one package. And that is known as computer software. So, for us people, we have these calculators, these computers that can do things for us if we just describe what the thing is or provide an algorithm, which is just a list of things that can be done repetitively. And also, of course, with a certain structural sequence, right? And there are many things that are just not worth our time to be doing repetitively. If you think about the Industrial Revolution, when we have people not having to plow fields themselves anymore and use all the labor of those labor animals, horses and cows and whatnot. When the Industrial Revolution came and we had machines that could do those things repetitively for us. It freed us up to do much more valuable, much more creative things. And the Industrial Revolution enabled us to automate things that require muscle to do, right? Now, with computers, we can automate things that require thinking to do. Now, ask yourself, what are the possibilities? Excuse me. Again, this is not meant to be a formal lecture. This is just a casual explanation. But just think. Think about all those repetitive tasks that you really don't want to have to do all the time. Well, computer software is the way to automate those things. You set it up once and use it forever, basically, if you set it up right. Thank you.